All right, here we will be calculating the pH of a weak acid solution. And what you'll see here is that we are using our tools that we learned during equilibrium. And that's because the way we would write this reaction is HBRO, and this is a weak acid. It's aqueous. Weak acids reach this point of equilibrium where they're forming H3O plus, and I could add right here to make that H3O plus, plus BRO minus. And so we have this equilibrium going on. And so what do we know? We're given the Ka right here. We are given the original solution, so not the solution at equilibrium. And we got to find pH. Now, pH is the negative log of the H3O plus concentration. So how do we find that? Well, let's set up our equilibrium expression. That's going to be H3O plus BRO minus over HBRO. Now remember, with a weak acid, we do not have all of these going to ions, so there's still some of this. Usually, especially with a Ka, this tiny, way far away from one, it's going to be mostly this in solution with a little bit of these. But the nice thing with acids is what you'll see is typically this 1-to-1-to-1 relationship. So we don't have any of these exponents up here to deal with in the expression. So what we're trying to find is we have Ka and we're trying to solve for this. Now, how do we get there? Well, this is where we use that ice table that we've learned about starting with equilibrium. So I'm going to write my ice table. I'm going to rewrite my equation here. Okay, so I started with 1.7 molar here, 0 of these. So it's going to shift to the right. So I'm going to plus X here. I'm going to minus X. So now I can start filling in my table. Now, before I do that, what we're going to see in this class is with these tiny Kas that we can make this X a small approximation. So X is going to be so small that it will not influence the magnitude of this because the order of magnitude is so much smaller. So let's, we can check it. If we put the 1.7 over 2.3 times 10 to the minus 9th, that needs to be greater than 400. And it is, it's way larger than 400. So we're good to go. So now let's plug them in. So we got Ka, we know that is 2.3 times 10 to the minus 9th equals, we have an X, and we have 1.7 on the bottom. And so we're going to multiply that 1.7 over here, and we get X squared equals 3.91 times 10 to the minus 9th. A little bit larger. Then we're going to take the square root of both sides. So we get X equals 6.253 times 10 to the minus 5th. And now I can use my equation because X, right? X is this. So we now have the concentration of H3O plus in solution. And so we can put negative log of this number. And I get 4.2. Weak acid should be less than 7, greater than 2 usually. So that seems like a reasonable number. So let's plug that in. There we go, 1 decimal place. So use those ice tables, use that X is small approximation with these small Kas. And you can see it's still, the pH is still pretty low, 4.2, even though it's got a small Ka, which means most of it, again, stays in this HBRO form when it's in solution.